we're back. And we're going to move on over to our problem that we started solving before break, or we looked at least. We didn't start solving it. Ooh, I hit end meeting. I hope I can cancel that. Okay. Ooh. Would have been the shortest segment ever. And we're back to our problem. So you must use this equation first because I want to compare this lab data to the reference data, which is right here. And let's just repeat the standard rotation for Paclitaxel using the D line of sodium and done at 20 degrees Celsius is negative 50 degrees. I fibbed a little on the number. I looked it up earlier and it's negative 49, but for math purposes, I think that error is it's okay. Paclitaxel is a potent anti-cancer medicine used predominantly to treat breast cancer, and it saved many lives. So it's a good drug. It's very toxic, but it's good. We have a 250 milligram sample of paclitaxel, and it's an enantiomer. So we need to know C, and we can't use milligrams. And apparently, we can't use calculators. I don't know if I've given you the speech about this yet, but we get feedback from people in pharmacy and medical school and dental school about how our students becoming so reliant on calculators have lost a sense of numbers. And it's this loss of a sense of numbers which sometimes lets mistakes happen later. You don't check your work, you just trust your calculator. But if you have a sense that 250 milligrams is a quarter gram, and you're able to think a little bit about fractions, I know that word scares a lot of people, but please don't just say 0.25 grams. Don't do that. You're going to have to do some very long math if you say that. That is 1/4 gram. The 5 milliliters is going to be used as is because we need milliliters. 20 centimeter polarimeter tube, can't use that. $20 centimeters needs to be decimeters. Now, I don't want you to do this math every time. Use the results that we get here. Say you forgot what a decimeter is. You know, deci's 1/10 and centis 1/100th. We can always go to meters first. You got 1 big meter for 100 centis. And then I got to get rid of meters and make a decis. There's 10 decimeters per 1 meter. And just remember from this day forth that you divide this by 10 and you get the answer. So you just slip the decimal one time. You don't have to show me this work on a test. Please just write down 2 decimeters. And I'll highlight that. Maybe not. 2 decimeters. And we have a 1/4 gram. And we have, unfortunately, green was my color for milliliters. So the 3 numbers that are relevant for us here are 1/4 gram, 2 decimeters, and 5 milliliters. So now I can calculate the specific observed rotation. So that's the standard rotation for our lab value up there. And the lab value for the rotation was 3 degrees. And it's got a plus sign in front of it. I know you don't see a plus sign, but if there's no negative, it's assumed to be a plus. Now that looks like a 4. Plus 3.00 over the grams. 1/4 over, it's grams per milliliter. Please remember that, over 5. And the path length was 2. I will always have numbers that simplify here. There's multiple ways to go. You can say, what's a fifth of a quarter? And that's 1/20th. You can go there. Or you can simplify a quarter times 2 to a half. Do you want to do that first? It's up to you. A quarter times 2 is a half. That's a 2. And a half over 5 is a tenth. So plus 3.00 degrees over 1/10. And that's going to be flipping the denominator to put it in the numerator. It's going to be 30 plus 30. Okay, plus 30. Now, I could have done some work before I started and compared this sign right here to this sign right here. And I know some important information right away. So before doing any math, I could have done this. Doesn't matter before or after. Here's my symbol for therefore. Paclitaxel is, the only question you have here, do those signs match or do they not match? If they match, paclitaxel is the major isomer. And if they don't, such as in this question, paclitaxel is minor. So if you get a final answer of more than 125 milligrams, which is half this value, you know you've done something wrong. So remember, paclitaxel is minor, and that's strictly based on the signs. There's only two scenarios. Do the signs match? If they match, then the pictured molecule is major. If the signs do not match, the pictured molecule is minor. I only ask about the pictured molecule every time. I never ask about the enantiomer. Okay, so we are ready to use the second equation where we can compare a standardized rotation in the lab to a standardized reference rotation. And there's a reminder right here. This is alpha ref right here. We can calculate percent EE. You take the absolute value of 30 over negative 50. The sign will disappear. Times 100. No calculators. So just remember, 100 over 50 is 2. And 2 times 30 is 60. I'll show that work right here. 100 over 50 is 2 over 1. And 2 times 30 is plus 60. Well, everything's going to be plus here because it's the absolute value. Yeah, it looks messy. Just leave it at 60. Not going to grade you on sig figs here, okay? All right. So what does this mean? Please try to, 60% is not a final answer. We're about 2/3 of the way there. 60% EE means there's 60% more of the enantiomer in this question than there is paclitaxel. Okay. So we already figured out which was major. So we have 60, that's not degrees. Quickly make that into, that says 60 degrees. That's crazy. 60%. Okay, we have 60% more of the enantiomer than paclitaxel. Now, if you love math, we now have 2 equations and 2 unknowns. I know a lot of you like doing that. And I have a way that's more directly referencing optical rotation and the actual excess. So I'm going to set up 2 equations, 2 unknowns. I'm not going to solve it that way, but if you like it, you can use it to solve it that way. Remember, there's only 2 molecules, so whatever you have for X and Y has to equal 100%. And X minus Y, major minus minor, has to equal 60%. And you can solve and all that good stuff, and you'll get 80-20. But don't do that. Here's what you do. Here's what you do. 60% EE means 60% major plus the other part of the solution that doesn't rotate light. Do you remember what that is? What that's called? It's 40% racemic. Yeah, where'd I get the 40? What's 100 minus 60? 100 minus 60 is 40. Let's get a little line between these things so we don't think they're related. We're moving on to a new part. Okay, what does racemic mean? 50-50 major minor. 20% minor plus 20% more major. There's your 80% major, which I don't care about in this question. Why do I only care about this one? Paclitaxel's minor. I need to know how much paclitaxel is present. And now you're cringing because you're still not allowed to use your calculator. Never. How do you do 20% of the total? Total. 250 milligrams, right in the question. What's 10% of 250? Breaking numbers into percents is good practice. Because if I do that twice, that's 20%. 20% of 250 is 25. Do it twice to get 20%. Your answers are here. Paclitaxel. Paclitaxel. Now it looks like paclitaxid. And there you have that. And that is a sample answer to a question. Every practice exam has one of these. So look forward to it on a problem set and potentially on an exam in your future. And we'll make that a nice short segment. That does bring to a close chapter 3. Try to do as many of these as possible and always be reviewing things. So you've got a nice new molecule here. You could determine all the functional groups in that molecule, bunch of esters and alcohols. There's an ether in there and an amide. And do stereocenters if you add wedges and dashes that are missing. And I look forward to seeing you after the break.